Next week in lab we're going to do experiment 8, and I wanted to go through some of the necessities that are required to properly prepare a flow chart. Your flow chart will count the same as a quiz grade, and it's due at the beginning of lab next week. So put some effort into this and some time, and go through this carefully as you read through the book and through the lab manual. What we're going to start out with next week is a mixture of 3 ions. We're going to have lead 2+ ion. We're going to have silver 1 ion. And we're going to have mercury 1 ion, which actually exists as a dication species. You're going to take a mixture of these, and you're going to add 6 molar HCl. So just a few drops of 6 molar HCl. What will happen is these 3 ions, which are soluble, will become insoluble and form precipitates. So you then end up with a mixture of the 3 precipitates: lead chloride solid, silver chloride solid, and mercury 1 chloride solid. Now, in the textbook, you will discover that it talks in detail about the separation of the group 1 cations. In fact, there's a large chart that's shown on page 721 that shows groups 1, group 2, group 3. And so if you were given an unknown and it had a mixture of those ions, it gives a general idea of how those things could be separated out. But for us, and what we're doing in group 1, there's a paragraph in the middle of page 722 that describes the separation of the group 1 cations in good detail. And so what we've got now is a mixture of these 3, and this is really where your flow chart could begin, but the way I have it up here is fine. I just want to illustrate a couple of points. First off, we've got to separate these 3 solids. So the question is, how can we do this? Well, one of these 3 is more soluble in hot water than the others. And in fact, in the procedure it says to remove this tube. In fact, most of the time what you do is, if you have a solid and a liquid together and you want to separate them, you take the test tube that contains the solid and the liquid mixture and you centrifuge that test tube. Well, if you do that, the solid compacts down nicely, and then you can decant the liquid off, which is a key part of the separation schemes that we apply in the laboratory. But what you're going to discover is if you were to add hot water to this, that one of these particular compounds is far more soluble than the other. And this is discussed on page 722. So what you're going to have here is kind of a separation in your flow chart. And you'll discover that it's lead ion that's far more soluble in hot water than the others. So lead chloride dissolves, and so you end up with lead ion in solution. Now, on the other side, you're going to have your solids that are not soluble in hot water. So you have silver chloride, you're going to have mercury 1 chloride, and again, these species are not soluble in hot water. And that's one of the keys to the whole idea of constructing a flow chart, is that your solutions are going to branch off to the right. So your soluble species branch off to the right. The insoluble components, or your solids, are going to branch off to the left. Do not invert this. It's very important. You don't have to write solids and solutions on there. What you should recognize is that in each one of these cases, I've indicated the phase of each one of these different metal species. So take this into consideration when you construct your flow chart. Now, the next question is well, how do we identify any particular ion? So we got our silver chloride, our mercury 1 chloride, and lead ion now is in water. So if you have the hot water present in the test tube and the lead ions in that water, now you've got a mixture of solid and liquid. So in the liquid state, we have lead ion. In the solid state, we have silver chloride and mercury 1 chloride. We need to separate these. They're in a test tube. We're going to centrifuge it. The solid will collect nicely at the bottom. The liquid then can be decanted off and put in a separate test tube. Well, that liquid would only have then the lead on it. And so we need to test that liquid to verify the presence of lead. In the book on page 722, it talks about what you need to add to test for the presence of lead. And it's actually potassium chromate. Well, once you do that, then you should see some type of color change or something should form to verify the presence of that particular cation. In fact, what you get is a precipitate with a very nice yellow color. And that lead precipitate is called, of course, lead chromate. So that's your solid. It has a yellow color or appearance to it. You should always indicate the phase and the color of that precipitate. The chemicals that you add to test or that are added are off to the right of the arrow. Anything new that forms throughout this process is just going to be in between the arrow at the bottom if it's the last point in that analysis. Over here on the left, notice again, I've got two solids. I need to separate them. A chemical is going to have to be added to accomplish that. This is discussed again on page 722, so you should look in your notes. Also for lab, it talks about adding ammonia here. I'm not going to indicate the strength of it. I'll just tell you ammonia is added here, aqueous ammonia. One of these, of course, will be soluble. It will branch off to the right. The other's insoluble. Again, look on page 722 for the remainder of the details of this. You should be able to figure it out based on what I've already indicated here. So make sure this chart is completed before you come to lab. It counts the same as a quiz grade.